We all know that the Maxwell's equations form the basis of explaining anything on electromagnetics. And in this video, we are going to see what is the physical meaning of Maxwell's equations 1 and 2. We know that Maxwell's first equation is Gauss Law, which shows del dot T equal to rho, and second equation del dot B equal to 0. Instead of just saying these equations, we are going to analyze what is the real physical meaning of it. In order to understand the physical meaning of these Maxwell's equation, it is very important to know what is meant by divergence, because we know that these two equations are based on del dot T and del dot B. So we have a full length video in our channel explaining on the divergence. But here we can have a quick catch up on the divergence. So it states that if we have a vector field F, and if we have to find the divergence of that field, it actually measures the tendency of the vector field to diverge from a point or converge to a point. So let's see what it is. So in an analogy, let's consider water is our source, and water is our field and OC is our source. We can say that the water, that is the fields, are coming out of this source, that is the OS. So here also we can see that if we are considering this as a source, we can see the fields are coming out of this source. So if the fields are coming out of the source, we will say this as a source, and we will say the divergence is positive. That means vector fields are diverging from this point. And in case means as we are considering water as the field, let's see what will happen if we have a sink. Sink means water is going through that sink. So the similarly, if we are considering this as a sink, all the fields will be uh, coming to that point. In that case, we can see that it is converging through that point, or we can say that divergence is negative. And if we have like both O's and the sink at the same point, we can say that all the fields or all the water coming from the O's is going through the sink, and in this case we can say that divergence is 0. So this is a graphical representation. We can see here that if we have a source here, the fields will be coming from the source, and we can say the divergence is greater than 0. And if we have a sink here, we can see that all the fields are coming towards the point, and we can say divergence of that field is less than 0. And if we have fields like this, that is every field what is coming towards this point is going away from that point, we can say divergence of field at this point is 0. So this is the basic concept of divergence, and we are going to use this divergence concept to explain Maxwell's 1 and 2 equations. Let's see the first equation, Gauss law, which states that del dot T equal to rho. That means divergence of the electric field density at any point is equal to the volume charge density at that point. So when we consider the electric field, we know that all the electric fields will be coming from the positive charge, and it will be ending at the negative charge. We know that if we have an atom, we can separate out the positive charge and negative charge by ionization. That means it is possible to separate out both plus charge and minus charges. So we know that if we are considering a plus charge, the electric field will be coming out of this plus charge. And here we can see that as the fields are coming out, this is like a source. And here, when we consider a negative charge, we can see that all the electric fields are coming towards the point, and it is like a sink. So in this case, the divergence is positive, and in this case, as it is converging, the divergence is negative. So let's see what is meant by this equation. So let's see a closed surface which consists of equal plus charge and equal minus charge. Sorry, this is plus Q. So here you can see that it is consisting of two positive charges and two negative charges. This means that equivalent charge from this closed surface is 0. So if we consider the electric field from these charges, we know that this electric field from this plus charge will be coming out and it will be ending in minus charges. Similarly for this pair of plus and minus charges. So if we consider this surface as a whole, we know that there won't be any total electric flux coming out of this surface. That means that the flux coming out of the surface will be zero. That means that the flux coming out of the surface is equivalent to the total charge enclosed by that surface. So if the equivalent charge inside the area is zero, that means that there won't be any flux coming out of this area. Let's see another example. Here we have a two positive charges and one minus charge. So in this case, this electric field coming out of this plus charge will be ending on the minus charge. But in this, for this plus charge, the field coming out of this plus charge will be going out and it will be going to any other negative charge in different areas. So if we consider that closed surface, we can see that there will be total flux coming out of the surface because of this plus charge. That means in this case the divergence is positive as we have a plus q charge here. Similarly, if you consider this scenario like one positive charge and two negative charges, we can see that the field from this plus q will be ending on this minus q, and the field from another plus q will be going towards this minus q. So in this case, we can see that here we can see that there is a total field coming towards this closed surface. That means that if we have a total charge as a negative, the divergence will be negative. That is the indication of this equation. That means that the total flux coming out of a closed surface. In these three cases, we see that the total flux coming out of the surface will be indicated by the total charge enclosed by the surface. That is the meaning of this equation. This also indicates that in case of an electric field, this source can be separated as the plus charge and minus charge because we can separate out positive charge and negative charge by ionizations. Let's see what's the second law. This is Gauss law for magnetism, which shows that the del dot B equal to 0, the divergence of magnetic flux density B at any point equal to 0. This means that in previous case we have seen that the electric fields are coming from the plus charge and going to the negative charges, and we can separate out plus and minus charge as the separate entities. But in case of a magnetic field, we know that the electric fields are magnetic fields are forming a closed loop. It will be forming loops like this because it will look like it is coming out of the north pole and ending on the south pole and going inside the magnet and forming the closed loop like this. So as it is forming a closed loop, there is no flow of field coming from this closed surface. So whatever the closed surface we are considering, all the fields will be forming a loop and it is not going out of this closed surface. This actually means that it is not possible for us to separate out North Pole as an entity or South Pole as an entity. But in our electric field case, we were able to separate out plus charge and minus charge. But in this case, these are forming the closed loops, so we will not be able to separate out North Pole as it is or South Pole as it is. That is the meaning of this equation. That is, there is no magnetic monopoles similar to electric monopoles. That is, if we have a magnet like north and south pole like this, even if we cut or if we try to separate north and south pole by cutting at the middle, we can see that each part will be having north and south pole. So we will not be able to separate out North Pole as such or South Pole as such because the field coming from this magnet is forming the closed loops. That is the meaning of this equation del dot B equal to 0. That is, Gauss law for the electric field states that we have the electric monopoles, and the fields will be coming from the plus charge, will be ending on the negative charge. And in case of the magnetic field, there is no magnetic poles, and all the magnetic field will be forming the closed loops. That is the physical meaning of these Gauss laws. I hope you understand the concept of Gauss laws for electric field and magnetic field. Thank you.